Welcome to page 2 of the Skill 4 notes. Please make sure you've already completed page 1 of the Skill 4 notes so that you're ready for this one. If you have not yet completed page 1, please go back to that video. All right, so for this page of notes, we're going to work on the opposite of what we did earlier. We're going to work on writing whole numbers as equivalent fractions. So we're going to take a whole number and we're going to talk about different ways to write it like a fraction. This is going to be helpful here when we're adding, but it also gets really important as we move into other fraction skills, and then as you move down the road into your middle and high school math and into algebra. So the big idea here is that any whole number can be written as a fraction. There's a lot of different ways to do that, and it depends on the denominator you're using. Let me show you what I mean. For starters, I have these 2 yellow hexagons. I'm going to color them in yellow and invite you to do the same. These are our pattern blocks, and they represent one whole. So looking at this drawing, if you were asked what whole number is being shown, you should recognize that this is the whole number 2, because there's one whole number here and one whole number there. 2 by itself is just a whole number. If I want to write it like a fraction, I can write that there are 2 pieces and they're each whole numbers. So I can write the number 2 as the fraction 2 over 1. It means I have 2 pieces and each piece is one whole. Pretty simple, but kind of strange looking if you've not seen it before. Moving on from there, I could say, well, I want to just still show the number 2, but I want to write it with a different sized piece. So looking at these, I can see I still have 2 whole amounts, but they're cut up into those red trapezoids. So I'm going to grab red. Let's color those in so they look like those red trapezoids. I've got 1/2 and 1/2 and 1/2 and 1/2. So if I have the number 2 and I want to write it in terms of halves, I want to take 2 and chop it up into halves. I could draw 2 and cut them each in half and count how many halves. 1, 2, 3, 4. 2 is equivalent to 4 halves. But another way I could do that, if I had written this like 2 over 1, and I could think of it like creating an equivalent fraction. I want to write a fraction that's equivalent to 2 over 1. To do that, I said 1 times 2 is 2. Whatever I do to my denominator, I do to the numerator. I want to be equal. 2 times 2 is 4. And now I could take those same 2 whole numbers. I'm going to write 2. I could think of them like the fraction 2 over 1. And looking at these pictures, now I'm trying to cut them up into thirds, because they took each whole number and chopped it up into 3 pieces. So I've got 1/3, 1/3, and 1/3, 1/3, 1/3, and 1/3. Looking at these pieces, I could count to figure out how many 1/3 pieces I would get. If I took 2 whole numbers and chopped them up into thirds, I could count 1, 2, 3, 4, 5, 6, 6 thirds. I could also use my multiplication strategy. To turn 1 into 3, I multiplied by 3. To turn 2 into 6, I also multiply by 3. Whatever you do to the top, you do the same thing to the bottom. That keeps them equivalent. And then I'm going to color these in so they look like blue pattern blocks. Those 1/3 rhombuses. The big idea we want to take away from this is that any whole number, like the number 2, can be rewritten as a fraction by writing the whole number over 1. 2 ones. Once I do that, I can use the equivalent fraction strategy to multiply to turn it into any denominator I want. You might now be linking that back to the end of lesson 3, where we were figuring out how many pieces were in the whole number in order to turn a mixed number into an improper fraction. This is an extension of that skill and just a different way to look at it. So we just use the draw it strategy to prove what's happening, but like we keep noticing, the draw it strategy is helpful for understanding, but it can be a lot of work. It's not necessarily an effective way to do this quickly. So let's use the solve it strategy to show how to do that quickly. So looking here in the solve it section, it says rewrite each whole number as a fraction over 1, then multiply to create an equivalent fraction. So looking here, I have the number 3, and I know we can write any whole number as a fraction by writing the 3 and then writing it over 1, because I have 3 ones. This tells me I have 3 pieces and they're all worth 1. And now all I have to do to turn it into any denominator I want is to think about how to multiply. To turn 1 into 2, I had to multiply by 2. Whatever I do to the bottom, I'm going to do to the top. That's what keeps it equivalent. Oops, not a 3. I multiplied by 2, so I have to multiply by 2 on top. 3 times 2 is 6. So I know that 3 is equivalent to 3 over 1, and that's also equivalent to 6 halves. Let's try it again. Here I have the whole number 5. I'm going to rewrite that as the fraction 5 over 1. Then, to turn it into sixths, or to make it into a fraction that's equivalent but it's written as sixths, I have to use my multiplication thinking. 1 times something equals 6. Well, 1 times 6 equals 6. Now I can do the same thing to the top. 5 times 6 equals 30. So 5 is equal to 30 sixths. On to those try it problems. Remember, you have a choice here. If this is making a lot of sense to you and you're ready to work independently, try these on your own and then restart the video to check your work. If these don't make sense yet, you're invited to work along with me until they do. All right, I'm going to start here with my 4 equals some fifths. A sneaky way to do it even faster is to rewrite it 4 over 1 equals something over 5. 1 times 5 equals 5. So 4 times 5 equals 20. 4 equals 20 fifths. Let's keep going. I'm going to move on to this next one. 10 over 1 equals something over 9. 1 times 9 equals 9. So 10 times 9 equals 90. It's important I'm multiplying the top and the bottom by the same number. That's what keeps it equivalent. So 10 is equal to 90 ninths. 25 is equal to some thirds. So 25 over 1 equals something over 3. 1 times 3 is 3. 25. Ooh, I could do that in my head. 25, 50, 75. If you're not sure how to do that in your head, you could always set it up standard algorithm style to do 25 times 3. 3 times 5 is 15. Carry the 1. 3 times 2 is 6. Plus 1 more is 7. All right. Ooh, this last one is backwards. That's okay. I have some eighths equals 2, so I'll write that as 2 over 1. I need to go this way. 1 times 8 is 8. So 2 times 8 is 16. 16/8. Now the last one doesn't ask me for just one thing. It asks me to write 3 different equivalent fractions for the number 6. So I could say 6/1 equals, well, what if I multiplied it by 2? What if I cut it in half? That would be like 6 times 2 is 12, and 1 times 2 is 2. So I could rewrite 6 as 12/2. Now I'm going to try in my head multiplying it by 3/3. 6 times 3 is 18. 1 times 3 is 3. I could rewrite it now by multiplying it. I multiplied by 2. I multiplied by 3. Ooh, I like to multiply by 5, so I'm going to do that now. 6 times 5 is 30. 1 times 5 is 5. So these are all different equivalent fractions that mean 6. Please go back and check your notes to make sure that you have all your answers. I'm going to go back and fill in some of my blanks here so that I make sure I have everything I need. When